Hello, my friends. Have you ever been in a situation where the boss expects you to meet an impossible deadline from hell? Where the boss says you have to deliver something with only half the time and half the resources that you know are necessary to get the job done properly? Well, such things happen all too often in our software development world. And I know all about that because I've actually been developing software for almost 50 years, 45 years. Good Lord, that's a long time. Anyway, my name is Fred Fowler. I'm a third-level Professional Scrum Master, PSM3, certified by Scrum.org. And I know a lot about software development, and I've got the scars to prove it. And I've run into situations many times where bosses feel that in order to earn their pay, they have to press people to get things done in ever tighter deadlines. And I've seen the cost of doing that. The costs are very real, but they can get hidden. And so the purpose of this video is to describe what those costs are and what you can do to try to remedy that situation and not get into that bad cycle of push, 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 and the damage it does to applications as a result. And I've got three stories to talk about along those lines. The first one is about a situation where I was a Scrum Master coaching a team of people, and we were asked to do a certain enhancement, a certain improvement to existing software. And we came up with an estimate for how much time it would take. We estimated it would take 90 days to get this done. And the general manager of the division, who was famous for being very strict and a real pile driver of a person, he says, 90 days, that's ridiculous. You have 40 days, less than half of what we thought it was going to be. And why did he pick 40 days? Well, you see, he was just assuming that everybody, when they were doing estimates, was lying to him. He assumed that whatever the estimate was, it was actually inflated twice as long as it normally should be. So we said 90 days. That meant he heard 45 days was the real estimate. And then to put some pressure on us, some extra pressure, he cut 5 days off of that. So that's how 90 days become 40 days. He thought it would be really 45, but we're going to just make it a little bit more strenuous, only 40 days to do it. Now, unfortunately, this guy made a very basic mistake, which was that the 90-day estimate was an accurate estimate. It really was going to take us about 3 months to get this done. But he said he expected it to be delivered in less than a month and a half. And of course, his style was such, he says, either you do it or else you can go look for a job someplace else. So what do developers do in a situation like that? Well, they do everything they can to make it look like they met that deadline, even though they didn't. Their incentive was to try to lie and fool the general manager into thinking that they actually had met the deadline, but in fact they hadn't. And so the way it worked is they worked hard very diligently, and then 40 days later, they said, okay, all done. We give it to the QA people to test it. So we're all finished, test it, find the bugs, let us know what's going on. And of course the QA people did do the testing, and they found that there was lots and lots of problems. It didn't work at all. And so the QA people gave it back to the developers, say, okay, we'll fix this bug, fix that bug. And so the developers worked at it and then fixed, and then about a week or so later they gave it back to QA, say, okay, test it now. And of course it still didn't work. Lots and lots of problems. So they went into this cycle of test, bug fix, test, bug fix, test, bug fix. And in the end, they finally got the thing stabilized and working after 100 days. 40 days worth of so-called development and then 60 days worth of testing and break fixing. So what had happened? Well, it actually had taken longer than the original estimate because they had to stop what they're doing and go through this testing cycle stuff, and in effect they used the QA process to extend the deadline. They made it look like they hit the 40-day mark by delivering something to the QA people. But in fact, what happened was that it was a very incomplete, very bad job, and they used the testing, break fix, bug fixing cycle to get enough time to have done the job correctly. So, setting a very aggressive deadline of 40 days turned out to be counterproductive. But of course, nobody admitted that. They all said, well, it's hard to do software and you always end up with bugs to fix. But that's how that team dealt with that 40-day versus 90-day deadline. Now, the second story about that has to do with that same company, as about another insidious little problem that is a result of that kind of a technique for developing software. On a different project, a different part of this whole exercise, the team was supposed to do a small enhancement to something called an application program interface program, an API. Now, to understand that, the way it was all working was that this was it was a big retail department store chain that had an e-commerce platform associated with it. And the e-commerce platform had some front ends which were like apps, iOS apps, Android apps, and a website. And this interface stuff had to work with the engine in the back end, the fulfillment engine, which was a database-based thing. And in between the app and the engine, there was a layer that really translated the needs of the apps into calls to the underlying database application. That third layer was called the application program interface, or the API layer. And I was coaching a team whose job was to maintain and enhance that layer. And anyway, the app people wanted an enhancement. They said, well, we want our app to be able to show 3 pieces of information that are normally in the back-end database. And when we look at the screens from the back-end database application, we can see what we want. There's this piece of information here, that piece there, this piece here. So we just take those 3 pieces of information and then add them to an existing API function, so that when we call the API the way we normally do, it will actually return 3 extra pieces of information, these 3 things we want. And that was a very reasonable, simple thing to deliver. I've written plenty of software in my time, and when I considered this, I thought, wow, existing application program interface, existing API, 3 pieces of information that we can see them on the screen. That's maybe about 1 afternoon's worth of work for somebody to go and inquire the database and then add those to the return information from the existing API call. So, piece of cake. Well, it took the team more than 1 afternoon. It took 6 weeks. What? Not only that, it didn't take 1 person 6 weeks, it took 4 people 6 weeks to get it done. Now, why in the world should something as simple as that take so much time and effort? Well, the answer was that the application program interface code, the API code, was such a mess because of all of the shortcuts and quick and dirty things that people had done to it over the years, that it was very difficult to figure out what exactly it was doing. So, the team would make a change, and then something would break. And then they'd go fix that, and somebody else would break. After a while, QA was reporting that things that had been fixed months and months ago were all of a sudden reappearing. In other words, the code was so bad, and you make one change here, it actually has side effects elsewhere. And not only that, but when they tried to get the information from the underlying database in the back end, they found out that they were getting the wrong information. The database application itself was such a mess that what was being shown on the screen wasn't where it was supposed to be in the data files. It was coming from someplace else. So you had to reverse engineer what the heck was going on, what mistakes had been made which produced the result that was shown up on the screen, and then try to emulate that set of mistakes in the application program interface. And so finally, after like 6 weeks, 4 people working on it, they got it to sort of work, and they met the need. But that just shows you what the effect of having a quick and dirty solution, shortcut after shortcut can do. It can mean the difference between somebody doing an afternoon's worth of work and 4 people spending 6 weeks on something and the horrendous cost difference between those two situations. So anyway, that's story number 2. The story number 3 had to do with another company. Once again, they were a company that was doing some e-commerce stuff. This was an application that where you did financial transactions online. And the main product of the company that I was working for was a website where you logged in and did financial transactions. And the main complaint people had about the website was that it was slow. Customers would say they would log in and it would take a long time for anything to happen, and there were constant complaints about it. So, but anyway, I was a Scrum Master there, and I talked with the engineering management people and said, so how's the quality of the code? And they said, well, the code's pretty good. It's clean. There's a little problem here and there, but pretty much it's pretty clean stuff. We're happy with it. That's what the managers said. And then I asked the developers, the people who were actually working on the code, and they told me a completely different story. They told me about the Java class, Java program that had 10,000 lines in it. What? That's huge. They told me about the JavaScript that had 15,000 lines. What? That's bizarre. That's incredible. And then they told me about the CSS file from hell. What's that? Well, websites work with 2 different kinds of languages. One's called HTML, or hypertext markup language, and that's used to describe the content of the website. What words there are on the screen. What's it talking about? Now, the other one is called cascading style sheets, or CSS, and that describes not what the words are, but how they look, how they appear on the screen. What colors, what fonts, what graphics, things like that. And so to have a website, you need to have HTML code, and you also need to have a cascading style sheet to describe the look and feel of it. And cascading style sheets are they're a little bit, they're kind of simple things, but they've got an interesting quirk. You see, it's a great big text file. You can use Microsoft Word or some text editor to write the instructions in CSS in a big file. And when you load a website page, the browser gets the cascading style sheet file from the server and reads through it, and then it understands how it's supposed to make things look. So before anything else happens, it has to read through the cascading style sheet in order to understand how to, what typeface, what color, things like that. And since it's just a big text file, it's read from top to bottom, the way it works is that if you give it an instruction about how something should look toward the top, but then farther down in the body of the text file, you put another instruction that changes that. So in other words, if at the top it says make this red, but down at the bottom it says no, make this blue, what will happen is that the original instruction for red will be ignored, it will be forgotten, and the blue instruction will be the one that's used, because that was the last one it encountered. So a quick and easy way to change a cascading style sheet is just add something at the end. If you have an element that needs to look a certain way, you can either look through the cascading style sheet, the body of it, to find the original instruction and change that, or you can just put something at the end of the file which will override whatever happened already. So, anyway, what had been happening was that people had been doing that. They had been making changes to the cascading style sheet just by adding things to the end rather than looking through the body to try to find what the original instruction was and change that. And what was the result? Well, in normal world, a really big cascading style sheet file is maybe 300 or 400 lines. A really huge, complicated one can be like 800 or 900 lines. That's a very complicated cascading style sheet. Well, this one that they were working with had 40,000 lines. What? 40,000? I've written books about Scrum, and my books don't even have 40,000 lines in it. This thing was so big. Well, basically, to display a web page, the browser had to read through an entire book's worth of cascading style sheet instructions just to figure out how to make it look. No wonder things were slow. And why did it get so bad? It's because management was forcing people to get things done quick and dirty. Just change this from, italic to regular. And do it quick. You need to get it done quick and dirty, quick and dirty. But it's so difficult. I don't care how you do it. Meet the deadline. It's the I don't care how you do it that is the source of all the trouble. That's the really deadly thing to say. So basically the managers were saying, do it quick and dirty, cause these troubles, and after years of doing it, you ended up with a cascading style sheet file that was so huge it was impossible for anybody to make any sense out of it. So what's the moral of this story? The moral of the story is that you have to be able to do the job right. And if you can't do the job right, all that does is it stores up trouble for the future. Now, what are these kinds of problems? There's a name for them. They're called technical debt. Now, what's technical debt? Why is it called technical debt? Well, technical because it has to do with the technology involved. And debt because, in effect, it's something that you owe to the application. Technical debt represents work that should have been done, but was not done. That, in effect, you're saying we have to put this off for a later date. And if you're getting forced to meet impossible deadlines, you have no other choice. You have to say, okay, great, we're going to go ahead and take these shortcuts. We're going to do it quick and dirty because that's the only way we can make it look like we've done the job correctly. And of course the job isn't done correctly, and of course there is all kinds of trouble that is being stored up for the future. And after a while, the bill comes due. How does it come due? Well, the one way it can come due is that instead of taking an afternoon of one person to get something done, it takes 4 people 6 weeks. Another way it can come due is that rather than taking the time to go through and analyze the cascading style sheet, you end up in a situation where it's so big the performance and therefore the customer satisfaction is impacted. By the way, that cascading style sheet had the same elements defined and redefined up to 12 different times within that document. So the point is that you have to make sure that you don't get in a situation where somebody says, I don't care how you do it, just meet the deadline. The deadline is not as important as keeping the product clean and functional. Now, how does Scrum deal with this? Well, first of all, within Scrum, you don't have managers setting deadlines. Deadlines are things that are negotiated between the developers and the product owner. You see, the product owner representing management is the person who understands what the value to be produced is and can make an investment decision about whether it makes sense to pay somebody to go through the exercise of creating something or not. And then the product owner can decide whether something's worthwhile or not, but the product owner cannot dictate to anybody what the deadline ought to be. They could just say, this is what would be valuable. Now, within Scrum, there is a special meeting. It's called the sprint planning meeting. That's where the developers and the product owner get together and negotiate about the scope of the sprint. In other words, negotiate what the deliver is going to be and how soon it can be delivered. Now, the product owner has to make sure that whatever the developers deliver will be worthwhile, will be worth spending the money to pay them to do. The developers have to decide that whatever they want to do is something that is feasible, that can be accomplished within the time frame that they have in mind. And no one can tell the developers they have to do anything. However, since the product owner controls the budget, the product owner can decide whether the developers have done something or committed to do something that is worthwhile enough to be worth paying them to do it. In other words, there's a kind of a negotiation and an agreement. We'll pay you for 2 weeks, provided that you deliver what you say you're going to deliver. And it's up to the developers to say what they can or cannot do. And nobody can tell them that whatever they're going to do is not enough. They have to do more than they feel is doable. So anyway, the Scrum framework uses those techniques to try to bring the business realities in line with the technical realities. With the business in the form of the product owner deciding what makes sense to try to do, and the developers using their skills and their knowledge of the technology in order to commit to deliver a certain amount. And as a result, if the developers do their job correctly and the product owner does their job correctly, you end up with an application or with a product that is clean, is functional, is developed in the best possible time frame that's realistic, and you don't end up with technical debt problems that pile up and cause trouble. So that's the end of this story. The point is the developers need to be able to control what they agree to do, but then they need to be able to live up to that agreement. And the agreement that's made during the sprint planning meeting is something that everybody needs to respect, including upper management. And practice shows that when those conditions exist, you end up with the best possible results. You ended up with good, clean applications that are done in a cost-effective way, and you don't stir up trouble for the future. So that's the end of that story, and thanks very much for your time listening. Once again, my name is Fred Fowler. I'm a third-level professional Scrum Master certified by Scrum.org. I've been writing code for many, many years. I've taught a lot of people Scrum. I've taught more than 300 people how to be Scrum Masters and product owners. I've written books about Scrum. They're available on Amazon. And also Audible. I have a number of audiobooks I've done. And once again, I want to thank you very much for your time. If you like this, please give it a like. Better yet, if you want to see more of these, feel free to subscribe. Share the videos with your friends. And also, I read the comments that you write, so please feel free. Send me comments, and I'll be happy to read them and respond if I can. So once again, thanks very much for your time. Thank you for coming with me on our exploration of Scrum in the real world. Best regards.